Okay, several weeks ago, one of the vendors at the flea market that I do some business with brought me a few radios that he had picked up at an estate sale, and he wants me to repair them for him. Now, unfortunately, most of these radios are of the standard common variety 5-tube AC-DC type in very poor condition, busted cabinets, missing knobs, rusty chassis, etc. Well, I took them in, but I'm thinking to myself, you know, he thinks that he can get these radios fixed up and sell them and make money off of them, and that's likely not going to happen. He's likely going to go in the hole. I found out from my own dealings with trying to sell old radios in my area that are in much better shape that very few people want them. If they can't plug their iPhone into them, or if they can't watch a movie on them or whatever, then they're not interested. Now, yeah, you know, if they were $5 or $10, then maybe so, but you know, most people don't understand what all's involved in properly restoring an old radio. And when you tell them $50 or $75 or $100 or more, then they about have a heart attack. But yet they'll go spend hundreds of dollars on that modern day device that they can send a text message on. Generally, my advice for fixing old radios is only fix one up if you're planning on keeping it for yourself. If you're doing it to make money, then you're probably going to go in the hole. Yes, I realize there are some exceptions. There's a few people on eBay that seem to do real well at what I call over-restoring a radio and then selling a common 5-tube set for hundreds of dollars, but that's the exception, not the rule. And I basically told the guy that owns these radios all of this, and he still acts like he wants them fixed. So instead of doing a full restoration on these, I'm going to do just as little as I have to do to get them working. And if I find that there's anything major wrong with them, then we're not going to repair them. The first radio that we'll look at is this Admiral. Looks like something from the early 50s. Very dirty cabinet, crack in the top of the case. Dial string broken. One of the knobs is missing. Speaker cone is torn. Chassis has moderate amounts of rust and dirt. The power plug was missing, but I installed a power plug off of something that I cut off of a junk power cord. Okay, now let's fire this up. Well, actually, I'll tell you what the first symptom was. We had the usual filter capacitor hum, which I'll demonstrate now. And here's our familiar bad filter capacitor sound. Volume is turned all the way down. I'm not hearing any stations on top of the hum, so we likely have other problems. Okay, let's jump a good filter capacitor in circuit and see if the hum goes away. Now what we have here is one of these reproduction dual section filter capacitors. I think Antique Electronics Supply sells them or used to sell them. It's nothing that I have any money in. It's one that I ripped out of an old radio that I scrapped out. I keep a lot of these capacitors and such on hand that I don't have any money in for just such occasions as working on stuff like this. So let's connect this in circuit and see if the hum goes away. Well, that took care of the hum, but there's basically no audio activity, very minute hum in the speaker. Let's touch the center of the volume control and see if we get anything. Yes, we're getting something at the volume control. So that tells us that the audio circuit is working somewhat. So our problem is likely in the converter or IF stage, and the way we'll determine that is to check some voltages on the tubes and see if we can find something that's off, and then go from there. Wait a minute, a station magically appeared. It's weak, but it's there. So that tells us that our oscillator is probably working. Okay, back on the radio, I think we have some bad solder connections that's causing our problem. Because notice how when I bump on things, it stops playing. So let's examine those connections and see what we can find. And here's a capacitor that's blown apart, likely the across the line capacitor, AC line capacitor, so we'll definitely want to replace that. Here's an exploded view, literally, of the capacitor. And you can also see where it exploded. It left some black marks on the chassis there. Okay, I've hacked in a new line bypass capacitor, a filter capacitor, and the 39 ohm surge current limiting resistor coming off of the cathode of the rectifier tube broke on me as I was removing it to get to the terminal so I could solder on the lead from the filter capacitor. So I replaced that resistor with a 27 ohm. That's all I had in stock, and that value's really not critical. However, the radio is still not operating. The audio section is okay, but I'm not getting any radio reception now. My plate and screen voltages on all of the tubes seem to be okay, so I think we'll now fire up the signal tracer and see if we can determine which stage is dead. Okay, I'm checking at the control grid of the 12SK7 IF amplifier tube, which is also the output of the first IF transformer. And as you can hear, we're getting a radio station through the signal tracer. So that tells us that the oscillator and mixer stage, as well as the first IF transformer, is passing a signal. So the first stage of the radio is good. Okay, once again, we're on the grid, the control grid of the 12SK7 IF amplifier, and we're getting a signal. You see how high we have the gain turned up on the signal tracer. That's probably about normal, because there's not going to be that much signal coming off of the mixer tube and through the first IF transformer. So now that we have a signal here on the control grid of the IF amplifier tube, we'll move to the output of the IF amplifier tube, which is the plate pin number 2. Now don't worry, I have a capacitor installed in this signal tracer probe in order to block the DC plate voltage from getting up into my signal tracer. Okay, so let's turn our gain back down. Move our signal tracer probe to the plate and see what happens. Okay, we're on our plate of the 12SK7. Let's crank the gain up.
How do I get it all done? Logistics.
And as you can see, we have a nice stout signal there, and our gain is down much lower, so that tells us that the IF amplifier stage is working. So that proves that the mixer stage is working, as well as the IF amplifier stage is working. And we know our audio amplifier is working because we got a good buzz whenever I touch the control grid of the 12SQ7. So that basically leaves our detector stage. Okay, so we know our IF amplifier stage is outputting a signal into the primary of the second IF transformer. Now let's move to the secondary of the second IF transformer and see if we get a signal there, and it should be fairly stout. Okay, here we are on the secondary of the second IF transformer. And as you can hear, we're getting a little bit of signal there, but I have to have the gain turned all the way up. So that makes me wonder if possibly our secondary winding on the second IF transformer might be possibly open, and a quick ohm meter test will determine that. Okay, we're reading 25 ohms across the secondary winding of the transformer, so that's good. So here we are on the primary side of the second IF transformer, which connects to the plate of our IF amp tube, and you can hear the stout signal we're getting. However, if I move over to the secondary side, I get basically nothing, no matter what terminal I'm on. So, and we know our IF transformer is good. I've metered the windings and they check okay. So let's concentrate on these components here in the AVC and detector circuit. And here's where the second IF secondary winding goes into the 12SQ7 tube, which is our detector and first audio tube. Before I start checking components, we'll check the easiest thing first by substituting the 12SQ7 tube and see if that solves our problem. So let's find out right now if that's indeed what's wrong with this radio. Okay, well, substituting the tube did nothing, so let's start checking components associated with the tube. Okay, even though I don't think it's causing our problem, the AVC capacitor, which connects from one side of the AVC line to ground, as you can see, is very leaky here. So we might as well just go ahead and replace that capacitor while we're in here, and that will pretty much be the last capacitor. Let's see, this capacitor here couples the audio to the volume control. That's already been replaced. Our plate to grid coupling capacitor and the audio output stage is inside of this couplet here, which is a component combination, and that seems to be okay. We've already replaced the electrolytic filter and across the line AC capacitor, so all that leaves is this guy right here, and like I said, it's very leaky, so might as well just go ahead and get rid of it. Okay, replacing the AVC capacitor didn't really help matters any, which I didn't really think it would. So really the only components left is the volume control, and it looks like we have a small capacitor soldered across the volume control end to end, which could be leaky and causing the problem. Now the capacitor across the volume control is perfect. No leakage whatsoever. So yeah, this is going to end up being one of those weird repairs, one of those things that whatever's wrong will be one of those things that you never would have thought would cause the problem. Well, now I'm not even getting a buzz at the center of the volume control, but when I move to the other side of the capacitor, I get a buzz. So that tells me that either this capacitor that someone replaced is suddenly developed an open, or this is not a very good connection, or we otherwise have a short on the center terminal of the volume control to ground. Yep, we have a short from the center of the volume control to the chassis, which is circuit ground in this particular set. Now that part was easy, just a wire ever so slightly touching a ground pin, but now we're back to the same problem we had. Well, now we've lost our signal here going into the IF stage. That means this mixer stage has stopped operating. Just seems like every one of these radios that I get that I just want to do a quick service on them, get them playing in about 30 minutes and get them out of here, seem to turn into nightmares. If I get this one going, the rest of them that are in similar condition are probably not going to be touched by me. I'm just going to tell the guy, look, I don't want to see you lose your butt on these things. The best thing you can do is just sell them for whatever you can get out of them and be done with them. Because if you fix these things, you're going to lose your butt on them. Okay, I replaced the 12SA7 tube and got some reception back, but not nearly what it should be. I'm wondering now if the problem is possibly this second IF transformer. It may possibly be severely misaligned. Well, the alignment seems to be pretty close, but all that static and popping and cutting in and out sounds more like silver migration issues with the IF transformers, even though the voltage measurements I made earlier didn't indicate that, but that's starting to be the only thing left that I haven't really tested, and see, now we've lost it altogether. But I think I will take these IF transformers apart because that's about all that's left. And here's the second IF transformer all taken apart. And what was that I said earlier in this video about not doing any in-depth repair on this piece of junk? And look at what I'm doing. Okay, I've disabled one of the windings and I'm measuring across the capacitor. And we're reading 84 picofarads, so we need to find something close. I don't even know if I have anything in that value that is close, but we'll see. Okay, we've disabled the internal mica capacitors in the old IF transformer by just chipping away the mica sheet. I also had to glue this coil form in place to keep it from wobbling around once the mica sheet was disabled. And then I soldered two 100 picofarad capacitors. That was the closest value that I had on hand, across one across the primary and one across the secondary winding. I'll most likely have to tweak the alignment to compensate for the different value of capacitor, but it should still work okay. Okay, I have the IF transformer reinstalled. Let's power it up and see if any improvement is noted. Well, that's a little better, but we still have a long way to go. And we're not getting the static that we were getting before. Okay, I tweaked the IF alignment, and it appears to be doing much better now.
I am tired of hearing our...
That's even our weak station at 670.
An unrelenting force. I think is the only correct response. Accommodating up to 250. Delivery will go mainstream. It won't just be people in cities anymore. Businesses like you're in control. 601-485-3506. I'll do one event at a time.
Unless something else happens, all I have to do is do a little repair work on this speaker, and that'll be about all I'm going to do to this thing.
At the northeast.
I already done more to it than I said I was going to. Okay, I tried cleaning out the gap around the voice coil, and no luck. The voice coil is still rubbing. So technically this speaker either needs to be replaced or reconed. Am I going to do any of that? Nope.
Absolutely. Ryan, and even Baylor, that's fine. That's why I hope we go to...
It plays, it produces noise, it receives stations, and I think that's all the guy really wants. You know, it'll probably sit in this flea market booth for the next 5 years, and then I'll eventually wind up with the radio back again, and then
We're doing the show live.
I'll just gut it for parts to fix something that's in better shape. I mean, this particular radio, had it been one that was given to me or one that I'd bought for under $5, I wouldn't have done anything but scrap it for parts. Because this is basically an ordinary plain Jane 5-tube Admiral radio, and for what it would cost me to do a proper restoration, I could buy a better example of this radio and still save money.
I thought not only, you know, of the evening into the early morning hours of Thursday.
But there you go. That's about it. That's about all I've got for this video.
Moving across the region.
One thing I'm learning about these post-war All-American 5-tube radios made from 1946 up until the end of the tube radio era in the 60s is that silver migration issues are starting to be a real problem with these IF transformers. You know, 25 years ago, I didn't see that problem that much, but today it seems like I'm running into more of these radios that have that problem than not. And since the IF transformers are no longer available as new production parts, then we have to learn how to repair the old ones. Okay, that's it. Hope you got something out of all of this, and we'll do something else again later.
Sky Tracker weather